Day 17 of 90, and today we're tackling inheritance, the C++ feature you think you understand until it silently corrupts your game loop. I'm going to show you a hierarchy that compiles clean, runs without crashing, and calls the completely wrong function on every object. If you've ever wondered why your derived behavior vanished, or why a working class leaks memory in production, stay with me. By the end you'll know exactly when inheritance is the right tool and the 3 times it quietly betrays you. Here's our setup. A base class entity with a virtual update method. A renderable derived from it, and a physics body derived from renderable, overriding update to apply gravity. Now we store them, std vector renderable entities. We push back a physics body. We loop and call entity.update on each one. Run it and gravity never applies. The physics is just gone. No crash, no warning. The object is in the vector, but its behavior evaporated. This is object slicing, and it's the number one inheritance trap in C++. Let's look at memory. A renderable is, say, 16 bytes. A physics body is 40, it has extra velocity and mass fields. When you write vector renderable, every slot is exactly 16 bytes. So when you copy a physics body in, C++ copies only the renderable subobject. The extra 24 bytes and the table pointer to physics body's update are dropped on the floor. You stored a base, not a derived. The compiler did exactly what you asked. Value semantics plus polymorphism equals silent data loss. The fix is to stop storing objects by value. Use std vectors to unique_ptr renderable. Now each slot holds a pointer, the full physics body lives on the heap, table intact. Call entities, update, and virtual dispatch fires the correct override. Gravity returns. But pointers introduce a second trap. When that unique_ptr destroys the object, it calls delete through a renderable pointer. If your base destructor isn't virtual, you destroy only the base subobject, the derived part leaks. Run it under address sanitizer and you'll see the leak report immediately. So the rule crystallizes: any class with at least one virtual function needs a virtual destructor. Add virtual entity equals default, and deletion walks the full hierarchy correctly. This is non-negotiable for polymorphic base classes. And while you're there, think about the rule of 5. Copy and move operations belong at the level that actually owns resources, not smeared across every layer. Often the cleanest answer is to delete the copy constructor on the base entirely, forcing callers to use references or pointers and making slicing a compile error instead of a runtime ghost. Now the performance angle. Virtual dispatch isn't free. Every call dereferences the table pointer, then jumps through a function pointer the CPU can't always predict. In a render loop hitting millions of entities per frame, that indirection costs you. If your hierarchy is homogeneous and known at compile time, you don't need runtime polymorphism at all. Enter CRTP, the curiously recurring template pattern. You write template class derived struct entity, and the derived class inherits from entity physics body. The base call static_cast derived asterisk, this, update impl. No table, no indirection, the call resolves at compile time and inlines. CRTP gives you zero cost compile time polymorphism for the hot path. There's also the final keyword, mark a class or method final, and the compiler knows no further override exists, so it can devirtualize, turn a virtual call back into a direct, inlineable one. Use final aggressively on leaf classes in performance-sensitive code. The takeaway isn't avoid virtual, it's match the mechanism to the need. Runtime variety you can't know at compile time? Virtual. Fixed set, hot loop? CRTP or final? Here's your decision tree. True is a relationship with runtime polymorphism? Use virtual always with a virtual destructor. Homogeneous hot path hierarchy? Reach for CRTP. And if you're inheriting just to reuse code? Stop use. Composition instead. Day 17 done. Key takeaway: inheritance is a scalpel, not a hammer. Virtual destructors and pointer discipline keep it safe. CRTP keeps it fast. Subscribe for day 18.